Good morning, this is Mr. Morales, and this lesson is for Algebra 2, and today, as I mark up the board randomly, we're going to be discussing how to write numbers, rational numbers, in either radical form or exponential form. These two are another pair of inverses, just like adding and subtracting are inverses, multiplying and dividing are inverses, squaring and square rooting are inverses. In this case, you can have more than just square and square rooting. You can actually have whole numbers, or you can have numbers in general, with a fraction exponent that can be converted into the same exact number with a radical. So we're going to be learning how to convert from radical form to exponential form back and forth. And there is a whole process to it. First, we want to do is study some basic squares and cubes, because we're going to be doing a lot of multiplying of numbers times themselves, either squared or to the third or cubed. So times themselves 2 times, or times themselves over again 3 times. You could go any number you wanted of squaring and square rooting, but it doesn't really matter. So I'm going to just make a quick chart. Let's see, 1, 2, 3, 4, 5. Let's add one more. I'm going to call this my x numbers. I'm going to write the result I get when I square them, and then the result I get when I cube them. For example, if I have 1 squared is 1, 1 cubed is 1. If I have the number 2, I have 2 squared, which is 4. 2 cubed, or 2 times 2 times 2, would be 8. If I take the same thing for 3, I have 3. 3 squared would be 9. 3 to the third power would be 27. Then I would have 4. 4 squared would be 16. And 4 to the third power would be 64. And then finally, for this set of examples, I'm going to have 5. 5 squared is 25. And then I'm going to have 5 to the third power, which is 125. And basically, what we're going to learn how to do is go back and forth. If I give you a number and I asked you to square it, you can go to this column. If I asked you to cube it, you can go to this column. If I asked you to go in reverse, if I said, given this number, what's the square root? I makes you the cube root, you'd go 1, 2 over here. If I give you this number, which is the second power, and I say, give me the square root, you'd also get back to that number. So we're going to be doing this kind of equivalent, but we're going to be writing it out in a radical or exponential form. It doesn't make a lot of sense just explaining it like this. You really have to experiment and see the examples. So without any further wasting of time, I'm going to go ahead and just kind of go over the basics of what's going on here. So quick review. We do know that 3 squared means the same thing as 3 times itself again, twice. So 3 times 3, which would be 9. All right, easy enough. What I'm going to show you now is you could get the 3 again. You could take this 9 and take the square root of it, and you would get positive 3. So we're going to learn how to kind of go back and forth between an original form with an exponent and another form with a radical symbol. And just for your information, a radical is what we call the little house there. We usually say the square root house when we're taking something that had been multiplied times itself, but really it could be any root. You can have a third root, a fourth root, a fifth root. You can really do it if you want it. Today we're going to be playing mostly with the second and third roots, but we will introduce higher level roots as well. So let's get into the meat of today's topic with example number 2. So example number 2 says we have 8 to the 1/3. And up until this point, we really probably haven't experienced exponents that are fractions. So let me explain to you how you rewrite it to better understand it. 8 to the 1/3 can be written in what we call radical forms. You make a radical symbol. The base 8 goes in the house. The numerator becomes the exponent inside the house, and then the denominator becomes the root you're looking for. So what we're really looking for is the third root of 8. That means some number times itself and times itself again will give me the 8 that I have right there. If you go back to your chart that we created in the very beginning up here, we have the number 8 right there. And the number that was multiplied to the third power was 2. So in this case, the cube root, there you go. The cube root of 8 would be the same thing as saying 2, I want this locked, there we go. 2 times 2 times 2. Or in other words, the cube root of 8 is 2. Simple enough. What number to the third power? 2 to the third power gives you what's in the house 8. That's how you can check your answer when you have numbers. Number 3, let's practice this again. If we have 8 to the 4/3 power, we can write it in radical form. You begin with a radical symbol. Remember, your base goes in the house. The numerator becomes the exponent inside with the base in the house, and the 3 becomes the root. So what we want is the cube root of 8 to the 4th power. Well, I have no idea what 8 to the 4th power is. I believe it's 4,000 something, but that's not really going to help me. So what I'm going to do is expand this. So that's the next trick. When you have big numbers, or anything with an exponent, whenever possible, try to expand it if you can. So what does 8 to the 4th mean? 8 to the 4th means we have 8 times 8 times 8 times 8 inside this radical symbol. So basically 8 to the 4th power means 8 times 8 times 8 times 8. That still doesn't really help me too much. What I can do is I can separate each one of these little 8s and give them their own cube root house, because it's going to be commutative. So I can say, I basically have the cube root of 8 times another cube root of 8 times another cube root of 8 times a 4th cube root of 8. So I split this big one up here into 4 little branches. So each of these little 8s got their own little radical home that they live in. They're single. This is math I can actually do. From my table above, I want to know what number to the 3rd power will give me an 8. Or in other words, what is the cube root of 8? Well, I know the cube root of 8 is 2. Same thing with this one up here. This one's going to have the cube root of 8 is going to be 2. For the third one over here, the cube root will also be 2. And for the last one, the cube root of 8 will also be 2. So I can multiply all these answers now. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So to make this really short and sweet, I guess, I'd say the cube root of 8 to the 4th power is 16. And there's my final answer. So it's just another way of thinking of like dividing numbers, but by themselves, by a singular number. Multiplying and dividing can come up a lot. So let's try this again with number 4. Here we have 16 to the 1/4 power. So let's go ahead and let's just write it in radical form. So we have our radical symbol. We have 16 in the house. Now it's to the 1st power. Anything to the 1st power is just the number that you have right there. So I'm going to just leave it as a 16. If you really want, you can write the one there to show that it truly isn't disappearing anywhere. And then I have the 4th root of 8. All right, so I need to know what number times itself 4 times. So some mystery number times itself again, times itself again, times itself again will give me 16. And if you look back at your chart, take a quick second, you should get that the answer in this case would then be 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the 4th root of 16, the 4th root of 16 is positive 2. So there's our answer there. Pretty simple. It's just another way of thinking about multiplying and dividing. It really is. Now for example 5, we introduce the idea of a negative exponent fraction. Not a big deal. Here's the big idea. Whenever you see the negative sign up here, that just means you're going to make this into a fraction. Period. Once you have that, treat it as 8 to the 1/3. I'll make a radical down here because we're going to be turning it into radical form. 8, just like before the base goes in the house, it will be to the 1st power, and we're looking for the 3rd root. No big deal. The 1 stays on top. We're not doing anything mathematically to it. So we need to ask ourselves, what is the cube root of 8? What number times itself again will give me an 8? If I look back at my chart, I know I get a 2. So basically, what we have then to summarize it is 8 to the negative 1/3 power is equal to 1/2, period. So this isn't as intimidating as it may first look. Let's go ahead and try number 6 now, example 6. So we have 125 to the negative 2/3. The first sign is that this negative means I'm going to have a fraction. All right? I'm converting everything into radical form because it's already in exponent form. So my radical symbol. What goes in the house? The base of 125. It is being raised to the 2nd power, and we want the cube or 3rd root of it. I don't know what 125 squared is, but I do know that 125 squared, what that means is that I have 125 times 125. I still don't know what that answer is, but I can split up each one of these 125s and give them their own little house. So that's exactly what I'm going to do. I have the cube root of 125 times 1 over the cube root of 125. So I split up the individual 125s, gave them their own cube root radical house, I guess if I think of it that way. Now, I look at my chart and I go, what number times itself again will give me 125. And if you look at the chart that we made on the first side of the notes, we get the number 5. And whatever's on the first one will be the same over here because they're the same exact number. This is still not simplified yet. So if you don't remember how to multiply fractions, you multiply straight across the numerators. 1 times 1 is 1. You multiply straight across the denominators. 5 times 5 is 25. So to summarize this problem, I would say 125 to the negative 2/3, excuse me, I almost wrote a 1 there. Let me just erase it to make it nice, because I don't want to have it too messy. So 125 to the negative 2/3 power equals 1 over 25. There's our answer. We're just playing with numbers here, multiplying and dividing by themselves. Now we have the introduction of a variable. And it behaves very much the same way as it does with numbers. Only with variables, if you don't know what a variable is, it kind of just hangs around the end and you won't get one simple number answer. So let's practice this. We have 27x to the 2/3 power. We're going to go ahead and write that in exponential form, in radical form. So we have a radical symbol. We know we're going to have 27x inside the house there. It is being squared. The whole thing is being squared, not just the x. The 27x together are being squared. And we want the cube root. All right, what does 27x squared mean? That means 27 times x times 27 times x again, because it's squared. So I'm going to write it, and I'm going to use the commutative property. I'm going to say 27 times 27, because there's 2 of them, times x times x. Let me extend my radical symbol here. All right, so I've separated them. What I can do now is I'm going to go ahead and I'm going to separate the 27s. I'm going to give them their own cube root house. That is math I can handle. The x's, I'm going to pair them up as x squared. If I look at my chart from above, I know that the cube root of 27 is 3. Same thing with this one over here. But I don't know what the cube root of 2 is. I can go ahead and multiply this 3 times 3. I get 9 times the cube root of 2. Excuse me, of 2. That's supposed to be x. I don't know why I put that there. But if you're used to my notes, you know I'm making all these kinds of mistakes all the time. There we go. That makes a lot more sense. And it was x squared. That was a really horrible example, guys. I apologize for that one. I'm not going to lie. That was bad. So to clean it up, we have 27x in parentheses to the 2/3 power equals 9 times the cube root of x squared, not 2 like I had originally, because that would make no sense. For this one, when you're doing it in your notes, if you still have a problem understanding it, because I kind of messed up a little bit here, if you don't follow what happened over here, let me know and I can better explain it to you in person. But I'm going to keep going on because that's what I got to do. Number 8, I have the square root of 4x squared y. So now I have the radical form, and I want to go to exponential form. So we're going the other way now. Before, we wrote everything with the little radical house and simplified when possible. Here, we already have the radical house, or the radical symbol, I shouldn't call it a house. That's how I treated someone here. And then we're going to go ahead and write everything back in exponential form. So, square root of 4 times x squared times y. I'm going to go ahead and break these up into individual pieces like I was doing in my examples above. So I have the square root of 4 times the square root of x squared times the square root of y. Well, I know the square root of 4 is going to be 2. And then I ask myself, what number times itself will give me x squared? When you have squaring and square rooting of the same value, because that's really a 2, it's just invisible there, they cancel each other out, and you're just left with whatever's in the house, in this case an x. I don't know what y is, so that just stays square root of y. So to condense my final answer, I would say the square root of 4x squared y equals 2x times the square root of y. Now, I would be final, but I just remembered that I want to go back to exponential form, and I can't leave this as a radical. So I'm going to go ahead and keep the 2x in the front. And remember, I can write y to the 1/2, because 1/2 means the same thing as the square root. That was one of the properties we learned in the very first example. And just to quickly refresh your memory, let's say I had this, let's do the fourth root of z to the third power. Say I had that random expression there. If you want to write that in exponential form, you keep the z. Remember, the exponent in the house is your numerator in the fraction. Your root outside the house is your denominator. So that's a quick way to write anything that has a radical symbol into exponential form. So that's just a quick refresher. So this is truly the right answer. This is mathematically correct, but we didn't want to have the radical symbol. We wanted everything with an exponent. Because that's kind of like, the big idea of today's lesson, which apparently I keep messing up on. Now, when number 9 touches on what I just talked about in the last example, here we have b to the 1/2 squared. So what that really means, let me lock my screen before I move it around again and give you more nausea, is that we have b to the first power square rooted. Remember, if you don't have a number on the outside of your radical symbol, it's automatically expected that it's a 2. And then I have it squared. Well, we talked about this. When you are squaring and square rooting the same amount, you end up with just whatever's in your house, in this case, b. So that was a pretty basic one. And finally, let's go to number 10. This one's really easy. D, we don't know what it's equal to. All we can do is convert it from radical form into exponential form. So it's going to be d. The exponent inside the house is my numerator. The root on the outside is my denominator, and I'm done. So that's kind of the quick and fast version of the notes. I apologize for that little blender earlier, but it happens. If you want to do a better video for me, by all means, go for it. I'll even give you extra credit. All right, so have a good day. Good luck with your assignment. And of course, if you still have questions or need further examples, feel free to ask your teacher. Have a great day.